Alright, 1.4 Parametric Equations. Example 1. Describe the graph of the relation determined by this set of functions. Alright, now, parametric equations require a different mode on your calculator. So if you guys could please go to Mode, go down here. Instead of functions, you're going to go to PAR for parametric. Hit Enter. Then go to Y equals. Alright, so now you have x1, y1. Your x1, you're going to put square root of t, and for y1 you're going to put t. Then you hit graph and you get this. So describe the graph. Rather than describing it, I'm just going to draw a quick sketch. If I could draw a straight line, that'd be great. Something like that. Okay. Then it says, indicate the direction in which the curve is traced. Find a Cartesian equation for the curve that contains the parameterized curve. I forgot to draw my little arrows. There we go. Okay. The direction of the curve goes to the upper right. Just write that. Now, in order to give a Cartesian equation, what they're asking you to do here is just eliminate the t. So we have x equals the square root of t. I'm going to draw my t's in cursive. And y equals t. What I'm going to do here is I'm going to set both of these equal to t. My y is already set. Over here I'm going to square both sides. So I got x squared equals t. So if y equals t and x squared equals t, then y equals x squared. And looking at the graph, this is of course almost the graph of x squared. It's really only half of it, so I'm going to indicate that by putting x is greater than or equal to 0. Okay? Alright, you guys go ahead and try this one, and when you think you have it, go ahead and hit play. Alright, this is the answer that you guys should have gotten. Okay. Alright. Parametric curve, parametric equation. If x and y are given as functions, x equals f of t, y equals g of t, so basically x and y are in terms of t, over an interval of t values, then the set of points x, y equals f of t, g of t defined by these equations is a parametric curve. The equations are parametric equations for the curve. Okay? Alright, there's actually a mistake in this problem. This is supposed to be a 2 sine t. So 2 cosine t, 2 sine t. It's not going to make a big difference, but anyways. Okay, first things first, we need to graph this. Let me pull out my calculator. Alright, so on our calculators, we've got 2 cosine t. Just a reminder, make sure this is in parametric mode. 2 sine t. And graph. Alright, so we've got, it looks like a circle of radius 2. So let me go ahead and draw that. Those are the straightest lines I've ever seen. Not. Okay, so there's our circle. Find the initial and terminal points. Okay, initially t equals 0, so if you plug in 0 for each of these, you're going to get cosine of 0. If you guys remember the unit circle, cosine of 0 is 1. So 2 times 1 is just 2. Sine of 0 is 0. So the initial point is 2, 0. The terminal point, if I plug in 2 pi, cosine of 2 pi is the same thing. And sine of 2 pi is the same thing also. So the initial and the terminal points are the same. which makes sense because if this is making a circle, it starts and ends in the same place. Okay, right here. Okay, so indicate the direction in which the curve is traced. If you were to plug in points in between 0 and 2 pi, you would find that it's going this way. And then it ends up back over here. Alright, let's find a Cartesian equation for this. Now, if you guys remember the equation of a circle, the equation of a circle around the origin is x squared plus y squared equals r squared. In this case, the radius is 2, so it would be 4 because 2 squared is 4. This is the equation we should get. Okay, so the fact that you see that it's a circle kind of gives you a hint of what you need to do first. X squared plus y squared, if we were to plug these in, this squared plus this squared, this would give us 4 cosine squared t plus 4 sine squared t. I can pull out a 4. And if you guys remember from last year, your trig identities, cosine squared plus sine squared, that just equals 1. So this is 4 times 1, which is 4. So my Cartesian equation is x squared plus y squared equals 4. Alright?
Did any of this stuff ever happen to you?
You guys go ahead and try this one.
This one was.
Alright, this is the answer you guys should have gotten. They kind of threw a little bit of a curveball at you here. The bounds were 0 to pi. So you have a circle, but rather than going all the way around, it just goes from here halfway around. So the initial point is 1, 0. The terminal point is negative 1, 0. And then you do this the same way. You should get x squared plus y squared equals 1, which is the equation of a circle with a radius of 1. Alright, let's take a look at example 3. Alright, example 3. Graph the parametric curve. Let me change this back to parametric. Okay, so we've got 3 cosine t and 4 sine t. Go ahead and graph it. Alright, so let me change the window a little bit. Okay, it looks very circular, but if you actually count, it's 3 here and 4 here. So this is actually an ellipse. Let me go ahead and draw this. So it looks something kind of like this. Imagine this isn't so lopsided. Alright. Now, if you guys remember, the equation of an ellipse is something like this. We've got x over whatever this distance is, in this case it's 3, plus y over whatever this distance is, in this case it's 4. Okay? And this equals 1. Oop, forgot the squared. And to be honest, you could just leave it like this, since you know that's the equation. If you want to solve it using these, this is what you would do. You know it's x over 3 squared plus y over 4 squared. So just plug in these for x and y. So I've got 3 cosine t over 3 squared plus 4 sine t over 4 squared. The 3's cancel out, the 4's cancel out, so I'm left with cosine squared plus sine squared. And we know that this is just 1. So we have what we knew we were going to end up with, which is this. Okay? Alright, what portion of the graph of the Cartesian equation is traced by the parametric curve? It's from 0 to 2 pi, so it goes all the way around. Indicate the direction. Well, it goes counterclockwise. Initial and terminal points. Here's the initial point. This is also the terminal point. If you want, you can write it like that, or you can write it over here. Either way is fine with me, as long as it's clear that you're able to identify those 2 points. Alright, go ahead and pause here and try this one. Alright, this is the answer you guys should have gotten. Okay. Alright, example 4. Draw and identify the graph of the parametric curve determined by these equations. Alright, let's get the calculator out. Alright, so we got x equals 3t, y equals 2 minus 2t. Alright, so it looks something like that. Now we're really only looking from 0 to 1 because those are our bounds. So let me zoom in a little bit. Let's do negative 3 to 3. There we go. So this is our line. I'll go ahead and draw that over here. Alright. So the terminal, it doesn't really ask you to find the initial and terminal point, but if you plug in 0, you're going to get x equals 0 and y equals 2. 0, 2 is here. And if you plug in 1, you end up with 3, 1. 3, 1 is over here. So in this case, it's traveling this way. Okay. Alright, and that's really all they ask us to do. They don't ask us to convert into Cartesian or anything like that, so you can just leave it like that. Alright? Okay, go ahead and try this one. This one they do ask you to find a Cartesian equation, but I think you guys can do that, so go ahead and hit pause here. Alright, this is what you guys should have gotten. Okay, find a parameterization for the line segment with these endpoints. Alright. We're going to make this our t equals 0 and t equals 1. If this is when t equals 0, then x equals negative 2 plus some number times t. And this works because when t equals 0, x equals negative 2, which is what we have here. Likewise, y equals 1 plus some number times t, and once again when t equals 0, y ends up being 1. So this works for this point. So what I'm going to do here, if this is what it is when t equals 1, I'm going to plug in x and y and my t. Excuse me. So I've got 3 equals negative 2 plus a times 1, and I'm going to solve for a. So add 2 to both sides, you end up with a equals 5. Same thing over here. See here, y is 5. Subtract 1, b is 4. So, let me change colors. Green. Now I just need to plug in my a and b. So I've got x equals negative 2 plus 5t. And y equals 1 plus 4t. And there we go. Alright, you guys try this one. Oh, I forgot to put this is when t is in between 0 and 1. Because that was what I used over here. Alright, these are the answers you should have gotten. And once again, this is in between, when t is in between 0 and 1. There are other answers you could get if you decided to go from 0 to 5 or from different numbers. I like 0 to 1 just because it makes it a lot easier. And that's it. I'll see you guys tomorrow.